Okay, so hello everybody, welcome to the next JUG session. Today we have Fred from MySQL team to talk about the performance, basically all databases, but probably mostly MySQL. So help yourself to food even during the talk, and Fred, floor is yours.
Thank you very much. So let's start with some more details about who I am in the presentation. So my name is Frédéric Descamps. As you can hear, I'm speaking the most spread language in the world, which is bad English. So if there is something you don't get, just let me know and I will try to express it differently. Usually I'm French speaker, but I'm not from France. I'm from Belgium, as you can see it here. So if you want to follow me on social media or if you have any question, I'm always replying as much as I can. So you can find me on X, which I try to avoid a bit, but I'm still there. But you can find me on Blue Sky and on Mastodon too. I am working in the MySQL community team since 2016. Before that, I did a lot of stuff related on Linux and MySQL. And I am using MySQL since a very long time. I don't know if one of you are used to MySQL 3.20, but that was my first version I used. I have a blog, so if you're interested, there is some Linux stuff there, but much more about MySQL. But there are plenty of tips that I'm sharing in lefred.be, which is my website. So I would like to, before we go on the next slide, I would like to also know a bit my audience. I'm almost sure that you are, who is a Java developer? Okay, who's not? What are you if you are not a Java developer? DBAs? No? Other programming language developer? Okay. So nobody's DBA here? Nobody take care of, okay. Pity, because they're of course this session is, I try to make it very interesting for developers, but it also it's a database. At the end, I give also tips for database administrator, but who knows, maybe you will have to maintain a bit of database, at least for your test or unit test, that you could learn something out of it. Yeah, we will use, I will try to give you as much as possible some examples of what I'm talking to illustrate it. And I'm using a database that I call e-commerce. It is completely fake database, completely bad design, completely bad queries. It's made on purpose. But to be honest, it's not that far from the reality when you check what's happening on production sometime. So the first tip I want to share with you, and this is mostly when people are asking help on forums, Slack, mail, bugs.mysql.com, is that you should know your data. So which engine are you using? Which size is your database? So if I ask you an engine in MySQL, a storage engine, do you know any of them?
MyISAM.
You said MyISAM? Okay, you are a very good transition for my next slide. Please don't use MyISAM. But it's true, it's a storage engine. So if you are using my storage engine, my storage engine, I'm joking. Yeah, no, I'm joking. But please don't use MyISAM ever. There is they tell that every time somebody creates a table with MyISAM, God kills a kitten. So if you like kittens, please don't use MyISAM. So to do that, if you are a DBA and you want to annoy the developers, what you do set process default storage engine InnoDB. So you say, okay, I want that it is InnoDB only. I don't want any other type of database on my system. And then you just also disable the storage engine, right? Storage engine MyISAM should be disabled. And I don't know how many of you already edited MyCNF. Did you already play with the MyCNF? So it's the configuration file of MySQL. So if you have done it, please stop. It's not needed to do that anymore. As you can see here, now we have, since MySQL 8, this syntax to save the changes. and it's much better to not modify MyCNF. For some reasons, sometimes you still need to modify MyCNF, but it's very, very rare. And what you can do here is set persist. So if the variable you want to change, you can change it at runtime. So you do set persist default storage engine equal InnoDB. Now, at that point of time, it's InnoDB the default engine for everything you will do. And at the same time, it's stored, you will do. And at the same time, it's stored that the next time you will restore, or you will restart MySQL, the default storage engine will be InnoDB. Set persist only means that we cannot change it on runtime. So you boot that, and only at restart, it will be changed. Why I prefer this method to modify MyCNF is because here, when you do that, you have the possibility, if you go in performance schema, to see who changed what at what time. So this is quite more interesting than the MyCNF. And in MySQL 8, if you use the default, and when you use InnoDB, we guarantee the durability. So MySQL, it's we are very picky on your data, so we don't want you to lose data. So the defaults, you are full durable, full ACID compliant. Which sometimes people complain and say, oh, can you relax on durability? It's possible to relax, so it will be more performant if you have very bad hardware, but at the same time you could lose data. Then people say, yeah, but I'm almost sure that MyISAM is more, it looks more quick, right, than more fast than InnoDB. Then it means because your InnoDB is not well configured. Because if you configure it well InnoDB, like we do, this is our performance architect, Dimitri Kravchuk, who made the benchmark. And as you can see, InnoDB is much faster already in MySQL 5.7. So this was a full OLTP read-only. So now the other tip when you want to know what storage engine you are using, you can check also per table. So which are my storage engine, and if we run this query, so I will share the slides, of course. You will find them on the social media, but I'm sure that the JUG will also send it to you. I will share with them. So you don't need to copy or picture the query. You will have the slides. So we can see here, for example, this table has a bad engine. It uses MyISAM, and it should not, right? So this is the way you can check that. You can say, oh, I'm sure they would never use MyISAM. Run it in production. You may find some funny story there, because there are some third applications, depending on the version, for example, of Drupal or WordPress that you are using, that by default creates MyISAM tables, which is a very bad idea. So when we know the table, when we know the size, we should also something very, very important in MySQL when we use InnoDB, it's the primary keys. So I don't know if a lot of you, what type of primary keys do you create, but you should know that if you don't use InnoDB primary key at all, it's very bad, because what will happen is that the first unique key that is not null will be used as primary key. Most of the time, if you are too lame to create a primary key, you are as lame to create a first non-null unique key anyway. So there will be no primary keys. And what will InnoDB do at that time? InnoDB will generate one for you that you don't have access at all. So even if you do a copy of your server, maybe the primary keys won't match in the table space or between the two, because you don't have access to that. And these primary keys are shared between all the tables without primary keys, meaning that we have a mutex called Dixis mutex that will also, let's say, save this entry. And so if you have 10 tables without primary keys, and at the same time you write on these 10 tables, you're inserting stuff, the first insert will say, oh, what's the next primary key I have? And it will take the log for the mutex. Then the second one that arrives at the same time has to wait. That the first give the unlock the mutex, free the mutex, and gets the value it needs to use. Then the second one is waiting for that, but at the same time the third, the fourth, the 10 ones that are in parallel are all waiting for that mutex. So it's very bad for performance. So not having any primary key is the worst thing. Then, if you have a primary key, but the primary key is not good, what does it mean, a good primary key? Good primary key means short and sequential. That's the meaning of a good primary key for me in InnoDB. And if you, for example, here, this is a random primary key, completely random. And what happens here, and this is just inserting data in the table, right? I just insert data in a table space. And what we can see, I know you are not the DBAs, but the color here, it's the last LSN that are touched, in fact. LSN is just a number that the storage engine gave to do the MVCC in InnoDB. And what we see here is that at every insert, we almost touch everything, all the time. There is nothing that is called. Here, it's empty. It's a block with no data. But for the rest, we don't see anything called. It's all touch. Because, and we will see after, this is called the rebalancing the primary index. Meaning that when we store the data in InnoDB, we always store the data by primary key. Always. And if your primary key is completely random, when we insert the data, so I want to insert something, and this something has to come here, because this is where it should be when it's sorted. And if I don't have free space in this page, I will have to push everybody else to be able to insert the data there. So meaning this is rebalancing the data. You can say, yeah, but now with SSDs, who cares about that? Sure, random IOPS is much faster in SSDs. But if you have to do a random IOP or one IOP here to add a record, or change 2 terabytes of data, even if it's fast, it will be much slower, and it will be create a lot of IOPS for nothing. So if you have a good primary key, so sequential and small, this is what happens for the same inserts. So I'm inserting the same amount of data, and you can see only at the end we are adding. So we are it's happening the data at the end. So this is what you should do. So now that I said you should not have table without primary key, and you should have good primary key, let's have a look at how to find that. So this query provides us all the tables that don't have primary key. When you don't have a primary key, InnoDB will use the gen clust index. So this is the name of it, and that is shared between all the table without primary key. And so with this, you can see that, for example, in our example, the table e-commerce review has no primary key. So this one, it's a bad table. We should modify it. So let's have a look at this. So we take, so it was reviews. So we check how the creation of the table. So by show create table review, and we can see we have keys. So user ID, is it not null? Not really. So product ID, is it not null? Not really. And they are not unique, so they are not used as primary key. And we don't have any primary key defined. So this is, in fact, the bad table. So if you are in that position, what can you do as the developer or the DBA? The first thing you can do is, as I said, yeah, I didn't say about that, but we will also, if we don't want to create primary keys, because for any reason we have a legacy application or whatever, we can tell MySQL, please generate primary keys that are invisible for me. So now, MySQL, every time you will create a table that has no primary key, it will generate it for you. So that's something cool that is very new, that is new with MySQL 8.0.30, I guess. And so we will create the same table, but I will call it review 2, just to see the difference and to not modify the data we have already in review. So I create the table, and as you see, it's exactly, I just cut and paste the creation of the statement creation of the previous one, and I just changed the constraint name because they need to be unique in the full database. So I just add a 2 there. So we create this, and now if I check review with a description of review, we can see that MySQL has created this row ID, always the same name. When it uses a generated primary key, invisible, it will always call it my row ID. So it's my row ID, it's a big int unsigned. So you have a plenty of space to add columns there, to add rows. It's primary key, and it is invisible, auto increment. So this is the best primary key we can have. And now we have done this. If we really want to change the table we had before, because when we do this here, set persist, it means that only the new tables will have this primary key created if we don't specify it. But all the legacy we have already done in the database, MySQL won't change it. So what we do here, we just insert all the data from review in review 2. Then we drop the old table, we rename it, and now we have our table with the good primary key. Right? So let's have a look here now. So we select all the columns from the review that we just swapped. And what we can see here, we don't have primary key. So if our application was not expecting that primary key, it won't break or because it's not there. But in fact, if we want to see it, we specify it. So I use my row ID here, and we can see it. We have access to it. We can see it. And this is, I don't know if you know, but MySQL, it's very good. Usually developers, they don't care about that, but on the operators and DBAs, MySQL is very good because the way it can scale with replication, right? So you can have read replicas, you can have multiple machines to write data into it. And to do that, you need a primary key. Without primary key, replication won't work or will work very badly. And so with this, now replication works because replication will use this primary key. So now we know how to fix table without primary key. I also said bad primary keys is also an issue, right? So let's have a look to find what could be the bad primary keys, which meaning the primary keys that are too long or that are also that are completely random when we insert the data. So I create this query here that will check for the primary keys using InnoDB that are not integers, that are not using enum, that are not using date, time for the e-commerce database. And you can see that here for the table users, we have a column which is an ID. It's a varchar 36. So maybe it's good, maybe it's not good, but at least I have an idea to see this one doesn't seem to be a good primary key because 36 characters might be long and too long for a primary key. So let's have a look here. So we check the creation of this table, and what we see is that we have the primary key varchar 36, and it is the primary key. And what do we see here? What are these keys? Do you know? Do you know their name? What they are? They are index, but in MySQL, so we have the primary index, and these are secondary index. And there is something very also important, is that all the secondary index here, they have on the right most part, but completely hidden, we have the primary key added all the time. So here you see name is just the 101st character of name, but plus the full ID that we have here, it's here also next to it. So in memory and on disk, we have this information all the time. So every secondary index has the primary key. So when we do a search by secondary index, we will look up in the secondary index, and when we find the record that we need to use, we will do a lookup in the primary key because we have the value of the primary key. So this, if you're really interested on this design and how it works, you can go on my website or on the YouTube channel. There is a talk of more than 1 hour 15 only on primary keys, only that. And it's a lot of information, but we go into the details. I show you also the content of pages in binaries to see that there is the secondary all the time, the primary attached and stuff. So if you're interested, go take a look at there. There are some, you can find them. So now it means that watch out, all these secondary keys, they also have the primary key. So let's have a look to what are these primary keys and what are these? Who's using UID as a primary key here? Only you? Don't be, usually when I do kind of talk on to Java users, it's everybody, oh, UUID, we love them, and everybody use UUIDs. So here only one, I'm a bit surprised, but it's good. But I hate UUIDs as primary key when we store them like this. And I will show you how to store the UUIDs later, the best way to do that. But this way is very bad. And I will try also to explain you why. So here I do select of the ID, name, created, limit by 5. So what are these records, these 5 records? Do you have an ID? These 5 records are the 5 first one that we find in the table space. So the 5 first records that when if we scan the full table, the 5 first records start by Katie, and the 5th one is Benjamin, right? Now I will order by the creation then. So the first one that has been created, really, the first one that has been inserted in the table. And what we can see here, they are not the same. So what does that mean? Any idea? You should know what does it mean now.
Key is not ordered.
Keys are not ordered, so when we did all the inserts, what's happening?
It's rebalancing.
We rebalance everything. Good answer. So because you give me a good answer, you have, this is what you call a very special one that nobody has, is the 30th anniversary one. Sorry, if you can give it. This is the 30th anniversary. It's a very rare one. So you won. There will be other prize. So now you will answer the questions. So we can see that we rebalance the index. So every time we insert, when something changes, when here the UID change, it will move somewhere, right? Somewhere else. So to store the UIDs, if you have something like this, what we should do, we should store the UIDs as binary 16, right? Not as varchar, because varchar, here, let me see, go back. So varchar 36, do you know how many bytes it uses that it will add to every secondary index? Do you have an idea? You know.
I know.
So it will use 36 bytes multiplied by 4, because we are using UTF-8 and B4, so 4 bytes for one character, plus 2 because we are using a varchar to know the limit, because maybe we will put something that has only 2 characters in it, right? So you can see and it will add these bytes to every secondary index, which is way too much. So now, so when we do that here, if we create it as a binary 16, we will add only 16 bytes to every secondary indexes. I know a phone has a 64 megabyte at least, so who cares about these bytes? But when you are at scale, this makes a big difference. And then we use here, you see the comma 1 here, is the swap flag when we use UID to bin to change, in the binary way, to change the timestamp at the beginning. So now they will be able to sort them. So when we insert them, we will insert them in order. They will be sequential. So if you are using UIDs, not an issue, but you need to store them as binary 16 and swap them. So you do UID to bin, and you see here you have the value as a binary. So yeah. The thing is that you should always use the right data for your columns, right? If you use, I've seen, I hope you don't do that, but I've seen a lot of people that, for example, they use varchar even for integers, for numbers. Because MySQL always helped people, and it cast, so if you do 1 plus into quotes 1 pig, it will return you 2. Not 2 pig, but it will return 2, right? But it's bad because you are doing integers plus strings, right? But MySQL by default will try to cast by you. But this has a cost, and maybe it will be deprecated at a point. So please always store using the right data type. and as small as possible. For example, if you have limited values, use an enum. You will gain space. And if you have also columns that you don't really know what to put in it, or a lot of variables you want to put in it, don't use text or blob, use JSON data type. Because the JSON data type, it's in MySQL, it's optimized for queries, for replication, for plenty of stuff. So it's much better. And try to avoid text, blob, varchar 255 for everything, even if it's very small. Usually, what we can see when people say, they say, oh, I have an issue, this is my table, directly we can say, oh, you are a newbie. How do you know? Yeah, this is ChatGPT that helps you, because they use text for everything and they index all the columns. This is bad. So if you do that, please change it, because it's very bad for the database. You should not do that. So now here I will check all the columns that are blob, text, and varchar, and I will take a look at the size of these, the maximum size that they can handle in the column. And for example, here, product description is 55,000 characters. Maybe it's a very large description, maybe not, I don't know yet. But it seems strange to me. An email, 55,000 characters. If your email is that long, I'm almost sure it's generated, and you cannot give it by heart to your friends. It's way too long, right? A name, somebody that has such a long name, right? So maybe it's a bad idea. Let's have a look. An invoice status, varchar 10. Yeah, I don't know. We will see also that later. So first thing to do is say, okay, let's have a look at this description that Fred just talked about, and we check. We will extract the length of the description, and we will order by it and limit the 5 longest description. And what we can see is that we expect to have 55,000 characters, and at the end we have the max. It's 118 characters. So if we want later to index this type of data and stuff, it's a bad idea to keep it that long. So the best thing is to reduce it to something that will fit. Of course, that's up to you or the product owner to say, okay, we don't expect a description longer than this. And in my case, it's 150. So this is what we do. We just modify it, and now we have something that is more close to the reality. So invoice status, varchar 10, what could be the status of an invoice? We don't really know, but let's have a look. So we do that, and what we can see is that, oh, we have only 2 status in the database, sent or paid for the invoice. So why keeping that very long field for it? So what we can do is use enum, and it will use 1 byte only. Instead of 10, multiplied by 4 plus 2, right? So it's much better and if we index that. So to recap this first chapter, don't use MyISAM. Use set persist to get away of MyISAM. This is how to change a table from InnoDB to MyISAM. Keep your primary key. So this is, I didn't show it previously, but this is, if you are a DBA and you want to annoy your developer, you do SQL require primary key. So every time somebody will create a table without primary key, it will fail, just fail. And then you say, okay, try again, but this time with the primary key. Or you can generate a primary key for them. And if you don't know what to use as a primary key, it's always better to use a begin unsigned, not null auto increment. Okay. Yeah. We can also check which one are not unsigned, because there is no sense to have a primary key that goes in negative values, right? -1, -2. So, and then we limit the size of the maximum row we can have in the table. So it's always good to use unsigned. So you can find here the one that are not unsigned, because there are a lot of third-party products that don't use this unsigned when they generate tables. And if you use UUIDs, please use binary 16 and UUID to bin, UUID to generate it, 1 primary key, right? And please, yeah, just For fun, do you know which version of UUIDs are used in MySQL by default? Nobody?
You said a timestamp, so it's 2?
It's 1. So it's 1. And only 1 in MySQL by default. If you want other ones, you will need to add components or to add by yourself. But by default, it's 1. If, let's say, your product manager says, oh, you need to use 4 to be completely random, never use it as a primary key. Then use the auto-increment and put the UUID as a secondary index if it's a V4, because you cannot do anything with it. And please don't create such table with varchar like this, text. This is a very bad idea. Do you have any question on this? Are you still all awake? You have a question?
I have a question about this generate invisible keys. Is
Yes.
it default behavior or not?
No, you have it, but it's not enabled by default.
And why it's not enabled if it has so much
We
benefits?
might enable, for example, in our cloud, so MySQL is also managed in OCI by the MySQL team, it's enabled by default, right? But we cannot change the behavior right now, right? Because so currently it's not. But now we are in an innovation release, so we are in 9.2. So and I think the next LTS will be 9.4. So maybe 9.4 it will be the new default. So every time we do an LTS version, we change defaults most of the time. Not all of them, but we change default when we think this is important to change. So for example, one of the last we did, it was the raw format for replication. The format was statement and mixed, and for now it's raw only, and this is the default. That we do that type of changes, right? Other question?
Yeah, about the text type. Does MySQL, I don't think it stores them, doesn't it allocate like 65,000 bytes for the string now?
No, the thing is that it will allocate another page.
No,
So the InnoDB has a limitation, right? That and the limitation is you need to have at least 2 records per page.
Yeah.
So one page is 16K. So one record should be less than 8K to be able to have 2 of them there, because there are also some statistics and stuff. And there is always some gap and what you call it, checksum and stuff like that. So there you have, it's only 8K. So 8K, here we were more than 8K already, right? And what is text, blobs and stuff, if they are small, they will be on the same table. And if not, it will just point to other pages where you could have even 4 gigabytes of data for it, right? But having all these pages everywhere, and then the thing is that when you change them with replication and stuff like that, it has a cost. It could be very large. So if you don't need all that, maybe you should not use it.
Yeah.
And the price here is not when you create it. The price is when you will index it,
Yeah, I see.
and that's the issue.
And one reason why I switched some column from varchar to text was that if there's a varchar, there's a limit, and you insert something, then it silently truncates it. Then how can I avoid truncating that data?
There is a
Can it
warning.
grow or something?
There is a warning when it's truncated,
Yeah,
but most of the time people doesn't check the warnings, and
I didn't check either.
yeah, and but I will show you how to see them afterward. But yeah, there is no way to do that. So it's up to you to know. Okay, this will be my limit, and to know the limits, right? And maybe the application should know. Okay, I am inserting something that is 100 characters. You give me something that's 200. The application should say, oh, I will not allow you to insert that data because it's already too big to be added. But yeah, there is no magic. Sometimes that's the thing. But at the end, if you use text everywhere, it's a bad idea.
Yeah.
You had a question too?
Yeah. Does MySQL as of right now, or does it plan it in the future to have some tool to detect the right data type based on the existing data? So like I don't have to manually create queries that, for example, find what is the longest part what is the longest text, because I may have some like limitation from let's say product owner, but then we also have some existing data we don't want to lose and we want to update the type of them. It's one question, if there's like a tool or a nice way to do it. And second question is, what do you think about compound primary keys?
So first answering the first question, right? So you mean you have data in the database already, right?
Yeah.
And you want to see if they are too big or too not good.
Yeah, I would
And
like
then
to
you
like
say fix it for me.
Yeah, basically. I would like to like optimize
Yeah,
the data
there is
types.
none. I don't know any tools doing that. Maybe, yeah, I don't know. There is one tool called schema that helps you to keep history of your schema and modify them and stuff like that. Maybe they have something included for that. I have no clue on this. If not, no, you need to. For example, I have some scripts that you provide CSV files, and it parses the CSV and say, okay, from the CSV, this is the best table that you can get out of it, and this is the creation of the table that match the data you have. But in MySQL, there is nothing to do that. And compound primary keys, it depends. There is no issue if they are sequential, right? There is no problem with that. If they are not sequential, it's exactly again the same problem coming back.
Yeah, and only. What do you mean by sequential when they are compound? Like each of them has to be sequential?
No,
or
one.
somehow together they have to be sequential.
The first one, for example, should be sequential. So if you use a compound one, the first one should be sequential because this is how it will be written on disk.
Mm-hmm.
So, but now I don't know. Let's say okay, I have two IDs together, right? And then you say I enter. It's 1, 1, 1, 2, 1, 3. It's okay. But then you enter. Then you start entering 2, 1, 2, 2, 2, 3. Then it's 1, 4 now. 1, 4 will rebalance if there is no room anymore in the page for it, right? So that's the thing. You should avoid as much as possible this rebalancing. You can monitor that, see how many IOPS you do and stuff like that. But this is the danger you have.
Okay, thank you.
So index are important, not too much and not too few, right? So it is very important to not maintain index that you are not using, because maintaining indexes has a cost for MySQL. And the cost is not only when you write, but also when you select. Because the optimizer, when he creates the query execution plan, it will check all the possibilities to answer your question. And to do that, he will check if all the indexes that you have can help you. So if you have 10 index, it will check all of them and say, okay, can I use it? No. Or this one I can use it. Will it be better than the other one I was thinking to use? Or yes or no. And all this thing makes it slow at the end, because he has to go around all that information. And so it's a bad idea. And we should remove this index that we are not using. And we should also remove duplicate index. I know a lot of people say, I don't have duplicate index. I will show you how to can find them. And I'm almost sure that if you do that in production, you will have at least 1 or 2 duplicate index minimum. And of course, so you need to find the index that are not used. You need to find the index that are duplicate. And you also need to find, sometimes you are missing some indexes, because it's also something problematic. You do queries, and you don't use any index for these queries. And we will see how we can find that. So I don't know if you are familiar, but are you using schema in MySQL for tools using MySQL? Nobody? Good, you will learn plenty of stuff with schema today. So in schema, we have a table called schema unused index. So if we query this table, one thing very important about all these tables and about schema is in memory only. So it means all the entry that you have here, it's from when the database was started the last time. So if you check, if you say, okay, Fred told me to check all the unused index, let's start my MySQL and run the query. It's a bad idea. You will have plenty of them if you don't have nothing running on it and stuff like that. So you need to do that when you have several days of uptime, even months, and in production. But after a while, you run it, and it will give you all the index with this query that are never used for replying query, for giving you information, right? So these index are never used. Then you run there is another table called schema redundant index. You run it, and when you run it, it will give you, okay, for example, here we have for the table users, we have an index that is city index, and it indexes the column city, and then we have another index called city country index that use city and country. And it says here, this one is a duplicate one, because every time I search for, let's say I'm looking for Brno, I can use city index to find Brno, but I can also use this one to find Brno. So if I need this index for any reason, it's better to keep this one and delete that one. No need to have two indexes that helps to find the same queries, right? So now that we have found indexes that we can get rid of it, the best practice to drop indexes is the what I call blame the network. Let me explain. So instead of deleting the index, let's say you are not operators, but most of the time when we are operators, what we do, it's on the weekend we delete the indexes that we think we should delete, right? And so it's a Saturday, I delete the index, then it's party time, and I arrive Monday morning, a bit late and a bit tired, and then there is somebody blaming me already on the phone, saying, slow now, what have you done? And then you say, man, I need to recreate that index. But you already know that recreation of the index will take 1 day, or something like that. Then you say, yeah, it won't be done before next week. Could you stop your query, or it won't be done? Because it's an heavy task to create that index, right? So instead of doing that, Monday morning, you arrive, you say, okay, let's put that index that I want to delete as invisible. Optimizer won't see it. It will keep the MySQL will keep maintaining it, but it will never use it. Then you wait. The phone rings. The guy, oh, my report is very slow. What have you done? Are you sure? Alter table index visible. Seems okay for me. Could you try again? And maybe it was a network issue. And it works, and nobody complains. So the network issue, it's a very good idea. And use, so before deleting indexes, put them as invisible, wait a while, and sometimes it's not only 1 day, because the index can be used only for reporting that happens once a month, something like that. And when you are sure, make the maintenance to delete all these indexes, and all these indexes that you put in invisible, you can find them from information schema. You can have it here. This one is not visible, or you can also use show index from and wherever you want. If it's visible, no, and you have all the information, and you can see that this index is also not visible. MySQL is very easy. You can do plenty of bad stuff with it, and it will work. But there is one thing that he doesn't like when you have a lot of data. It is the table scan. Table scan is the only thing that scares MySQL. And so if you want to find what are the table scan, you can check which tables has been scanned by queries. And in this case, we can see that product, for example, has been a lot of rows have been scanned completely there, and it took 1 minute to do all that stuff. So now, so what do we know here is that we know that in the database e-commerce, for the table product, we do table scans sometime. We don't know when, what, but we do it. So we can do this query and find in the table product, find if there are something doing full table scans. And we can see that this one, it's close to the latency we have, and we can see that it has been executed more than 4,000 times. It never used index. It always did 100% of table scans, and this is the query. So this query, it's a bad query. We should add an index. Now, I told you adding index, it's very costly, right? And it's a heavy operation. And is there a way to make this operation better and easier? You as a developer, most of the time you don't really care, but this is more a slide for DBA. It is possible. So I won't go in completely all details, but there are some variables that will help us, and if we tune them, we can make it faster. So for example, here, with the default, I do alter table booking, and I want to add this compound index. And as you can see, it took 9 minutes to create that index. So it was not a very big table, but not small, it's on my laptop. But 9 minutes, can we improve that? So the default are InnoDB DDL threads 4, the buffer size 100 megabytes, and the parallel read threads 4 also. Yeah, if we increase them, they are also linked together, so it's always good to increase the other one. So I don't know if you know, but in MySQL, since MySQL 8, we can also now, for example, how many CPUs we have on the machine. Usually, so if you don't have access to the machine to see what's going on, from MySQL you can know, for example, this machine has 16 cores. Right? So I have 16 cores that I can share to do my alter statement, to add my index, and I have plenty of RAM free, so I will add 1 GB RAM for it. So what I do is say, okay, DDL threads 8, parallel read threads 8, and then 1 GB of RAM, and I run my query again. And if I run my query, what we can see here is that from 9 minutes, I went down to 3 minutes because of tuning that. But this is maybe not the best values, so it's up to you and usually the DBA to check. And for example, I did some tests, and for me, with 2 GB of buffer and only 4 threads, it went down to 2 minutes. So that was, but from 9 to 2 minutes, it's a big win. So it's possible to gain time on that. So remove duplicate index, remove unused index. When you do that, put them as invisible first. You can make it much faster. Don't forget to check for a full table scan. So do you have question on this chapter?
Yeah.
Yes.
You showed like the last SQL that was using the full table scan.
Mm-hmm.
Is this information always available, or does some special logging have to be done? Or
No, it's by default it's enabled. You need to enable that in 5.6, I would say, where performance schema was not enabled by default, but now it's there by default. So you have nothing to do.
yeah, but there is a setting for that. So
No, there is, but it's on by default.
but
You cannot run it without it anymore, to be honest, I guess, performance schema.
Okay.
You can reduce its size maybe, but you cannot run it without it because we depend for many stuff on it.
Yeah, that was a follow-up question. If it's hindering the performance anyhow.
Performance schema, it was in 5.6 and 5.7. Now, I would say we did some calculation. Of course, by default, I think it used something like 500 megabyte, but you can change that value. And the performance, of course, more you add metrics, you know, what you do, it has a cost. But the performance is less than 10%. And it provides you a lot of information, really, really a lot. What I show you, it's just a fragment of it. So you should really, performance schema, you cannot run without it anymore. And we will see again performance schema in 1 second. So other question on this? So something also very interesting is that your workload. You should know your workload. And this is fun because most of the time when I was doing performance tuning audits, I was asking people, oh, are you read or write heavy? The first answer was, we don't know. Or the other one, we write so much, we are write heavy. And then you run the query and you say, oh, woo, so many writes you are doing here. But look how many reads you do. Reads maybe because you are reading way too much full table scans or whatever, right? So it's always good to know that. And so when you ask help somewhere, you can say, okay, this is my settings, this is my the overview of my machine. I am doing most of reads because If you want help to tune your database, if we know that you read more than writes, it makes sense to make some different changes. And you can do that per tables. It's also nice to see, oh, why is somebody reading that much in this table, for example? Here it doesn't make sense, but when you do that in production, you will be surprised to what you can see. So we see who writes, who reads, and then there is something I always tell to the people and also to the junior DBAs. It's that once a week, maybe on the Monday to start, you need to find the ugly duckling. So you find that query that consumes most the query response time, because the query response time is the North Star that we all are looking for. This is the only metric that people are experiencing. All the rest, how many pages I've read, how many records I've read, who cares? At the end is the users that have done a click and wait. And this is experiencing, and this is what creates the frustration when it's too long, right? So we need to check who is too long and why. So we will check the response time, and we'll find the query that used most the response time, and then is the query that we need to fix. Of course, not every time it's possible to fix it. Maybe it's a write, and the write is slow because you are using slow disk, and then okay, if we cannot fix now the disk, we will do something else meanwhile. But when you run it, we use again this schema, and we do this query, and we will find at the end the query that was consuming the most response time. And it is the total response time. Maybe you have a query that it takes 30 seconds, but it's run once a month, 30 seconds. Who cares at the end? But then you have a query that takes maybe 10 seconds, but when in the main page, the first page, it's called 100 times. This one's consume most of the response time, because this one is the one people are experiencing the frustration, right? So we can check, and then we have here the latency per core, so it's not that slow, but at the same time, altogether, it is slow, right? So we need to find. So this is in our case, in our application, this is the query we should, at a certain point, think about reviewing. Maybe it's impossible to make it faster, but maybe it is. So, but this is the way to find the query that consume most response time. I know you developers, you don't like my next slide, but I love it. This is so true. So it's not, the problem is not the database. The problem is your query, right? And it's true. Most of the time, the problem is in the query. And so in performance schema, you can find, we have 5 tables that can help you to find what's going on. The first one, it's statement with errors or warnings. So for example, you don't look for your warnings, because usually when you type the query on the MySQL client, you will see the warning, right? Because you just type it. But when you use it in an application, the warning gets lost somewhere, and nobody cares about it. But here you can find them. See all the queries that return an error, or all the queries that return a warning. So it's nice maybe to check that when you do a test or on your application, run a select here to see, oh, did I have some issues that I have not seen or not? You can see it. Then you see all the statement that made full table scan, the one that are using 95% percentile of a response time, statement with sorting, meaning that you will use disk to sort the data. Using disk is slow. Statement with temporary tables on disk also, this is slow, right? So it is very, very important to check this table. So on the workload, check if you are read and write intensive, very good to know, because it will all depend, maybe not for you, but for the operators to make modification on the file system, on the amount of IOPS and stuff. Check the schema to what table, queries you need to optimize. And we also have now query sample text that you can have from performance schema. Before, this was not possible in 5.6 and 5.7. This provides you the full an example of the query, a query that you can run. Because usually you have, I don't know if I show it here. No, I don't show it. But you have a digest of the query. So with question marks, all the arguments are not there and stuff like that. Here you have the argument, it's there, it's an example. And something very cool is that if you have comments, they are also shown. This is also something I recommend. It's to use commands in your queries. So the DBA can, when it checks and say, oh, look, the query number 1 or whatever you want to name it, in the query production part, blah, blah, and you give the model as an issue. It contacts you and you say, oh, I have your query with that, this is the name of the query or something like that, that it's too slow or miss parameters, or you don't use limits and return so many rows that we don't know what to do with it. So could you check? Much easier for you to then grab the code and find where it comes from. So I recommend to use comments in your query. So who's using comments in the query already? Congratulations. So you are the winner of the night. You will have, for that nice effort, you see, at least you can think that you did something good with your comments. There is a cap for you.
Thanks.
So the next slide, maybe if it's too complicated, just let me know, but the query execution plan, do you know what it is? So it's very important to know that. And in MySQL, you have the traditional one. If you are using MySQL for as long as me, you love it. If you are a newcomer in the new developer and stuff, you hate it, right? So you can check that. So we have the traditional, the tree, and the JSON output. And JSON, we have 2 versions. We will have a look at this. The thing is that this, when you run and explain, this is an estimation. What does that mean? The query is not run. It means it's just what optimizer thinks it will cost you to run the query, but the query is not executed. So you do explain with the format. Who knew that there were different formats? Nobody? So that's good. You are learning some good stuff too. So there are formats. You can also have a variable that specifies the format you want by default, so you don't have to specify it again. And we have explained JSON format version. Don't know what happened. Okay, JSON format version that gives you 1 or 2, right? To change it. I will show you what it looks like. So this is the traditional format, right? That a lot of people maybe have used. This is the tree format. So if you are using Postgres, for example, it's more like this, the query execution plan. This is the JSON format version 1. And if you want even more details, this is the JSON version 2 format. So this gives you the most details about the plan of your query, what the optimizer will do, right? What you can do also is you can, if you use format JSON, you can store it in a variable. So you can run your explain, store it in a variable, and do whatever you want with the variable after that. For example, for me, with the variable, I can extract only the cost. It's possible to just extract the cost. And as you can see here, I'm using JSON notation to get out because my JSON data type, I think the native JSON data type was in MySQL first, even before Oracle database. So it has plenty of function to do that. Now, this was an estimation. Can we get the real numbers of my query? Yes, with explain analyze. So most of the time, people, when you go on forum and ask, they will tell you, please run explain analyze of your query. Watch out, if your query was taking 4 hours, it will take 4 hours to have the output. So maybe sometimes you say, okay, no, it's way too long, my query, I will not give you the explain analyze, but I will give you at least the explain. But with the explain analyze, we have the estimation of everything, but at the same time, we have the real numbers in milliseconds here. So this was the time spent for in the table scan of product to get the very first row. And then we went through all the rows in 18 milliseconds, right? The amount of rows we took, and if we were looping there, how many times we had to do that. So we could do this. I won't go into the details for this because we don't have DBAs around, but with the handler we could read that. But I will skip this. If you want, I can explain to you later about that. And if you want to know even more about what the optimizer do, if you are very interested in the optimizer, you can enable optimizer trace, run the explain, then select in information schema optimizer trace, and you will have so many information related to what did the optimizer. Something also that I don't speak here is that currently it's in development only in OCI, but we are adding a new optimizer in MySQL, which is the hypergraph optimizer. So that will give you even better query execution plans. So now, remember we had this first query that was the worst query we had. So the first thing when you have a query is to check, okay, what are the tables involved in the query. So here, this is the table we have. We have the table product, we have the table review, and this was the query. And this was the cost of the query, 5,000 something. So what could we do to make it better? So some tuning together. Do you have an idea?
Explain.
Yeah, we did, but we can do the explain. I think I showed it, but I will show it after. So first thing is the explain. But do you have an idea on what we can fix it? What could we do to fix it?
User ID.
Sorry?
User ID.
It's about user ID, you mean?
Yeah.
Yes, it's about user ID, but to select it won't. The cost, it's more when you write the data and on the size of your database and stuff like that. But for the query execution plan, it doesn't care. So that will not really what we know. But do you think that we need
Index for product's name.
index on product's name?
We are grouping by.
Yes. And I think we don't have any. Let me see. Product's name. Yeah, here I don't show the index. Index by product name. Oh, yes. And also here, what we can see is that. So what we would try to have is the name of the product and the amount of reviews they have. Is it interesting to know when a product has no review? Yes or no? It depends, right? If it's not interesting, one thing we can do to make it better is to remove the left join, for example. Just that will make it much faster. But let's have a look. So here, for example, if I replace the left join by a normal join to see what is going on, we will see that. Do I see the cost here? Blah, blah, blah. The cost will be much lower, so from 51,000 to 12,000. So just because I just skip the value that where I have no results, right? So this is one thing. Watch out. So you said, for example, oh, let's add. Yeah, it was not this index, but if you would say, okay, I will add a product ID and rating index, because you say, oh, I'm using product ID, I'm using rating, it will be better. The cost can be higher. So it all depends. So this is really something you should do, is to check your queries, try them, explain them, and check the cost. Because at the end, this is the only thing important, is the cost here. If it's too costly, it will be slow. Right? So explain to get the query plan, explain analyze to get the real numbers, but watch out, the query will be executed. So if it's a query that takes hours, it will take hours to get that. Compare the cost of the different queries. This is very important. You can verify the cost over time. I don't know if you are, but you are not DBAs, I know, but I don't know if you do that, but are you saving the cost of your queries? So, for example, in Oracle database, you can specify a query execution plan for a query and always keep that one, and that's it. You can stick that. In MySQL, not. So every time you will run the query, the optimizer will do his job and will find the best query plans it thinks about, and it will have a cost. But maybe if the statistics change after a large delete or a large insert, the query plan may be completely different, and so it's nice to check it. For example, here it's a MySQL shell module, because you can create plenty of module in Python or in JavaScript in MySQL shell, that compares query execution plan and their cost, for example. So if you're interested, this is on my GitHub. You can find it and install it and play with it. So you can, it will save every time the timestamp and when the query and what is cost. Do you have a question on this chapter? Yes?
What is the cost? It's like cost to optimize or cost to run, or
it's the cost that the optimizer thinks it will. So it's what is really the cost itself. I don't know. You cannot say, oh, this is money or this is milliseconds. It's the cost, right? I don't know the unit of the cost. It's optimizer cost, let's call it like that. And then it compares all the plans. It thinks they are the best, and it will always give you the lower cost. The lower cost is the query that will be executed, the plan that it will use to execute your query.
I see. And you also said that the optimizer will like redo the calculation on every time you do a query.
Yes.
How does this work with prepared statements? It's like per one prepared statement, or
no, per prepared statement, it will not cache the result, right? Or that it won't do. With prepared, I think with prepared statement it's about round trips more, but I don't know really if it has to redo the full because it usually doesn't keep it anywhere, right? So I think it does, but I need to check.
Yeah, I mean the execution plan.
Yeah. I think it will re-execute. It will redo it anyway, but I need to check. That is a good question. I have no clue on that right now. Yes.
Is it possible to somehow automatically not run query if it's about some cost, or at least get a warning if it's like after some threshold that I set?
On MySQL on-prem, no, right? On MySQL, but I will give you. I don't know if I have here some other limitation, but you can limit time, for example, that you can do, or limit numbers of rows that you can do. But the threshold, no. The only times there is a threshold related to the cost, it's in OCI, right? In the cloud of Oracle, if you are using MySQL there, we have also an accelerator that you can enable or not, that it's called heatwave. So when you have the accelerator of your query, then there is a threshold, and if you pass the threshold when you run a query, if you pass the threshold, then you will not run the query inside InnoDB. It will be sent to the accelerator cluster, to the heatwave cluster, when it passes the threshold, because there it will be much faster, and then you will get the information back. This is the only, so because we can do that, I think it's quite easy to implement what you just said about, okay, if I pass the threshold, I don't want to run the query, right? I think that might be possible, but yeah, it's a good feature request. Bugs, mysql.com feature request, but yeah, it's a nice idea. But it's possible because as we do it in the cloud for the reverse, instead of stop it but run it somewhere else, so we have the information, right? So we should be able to do that. Something also I want to talk about, but quite will be fast because we will run out of time. It's split your workload. When I started using even PHP a long time ago and so on, people were always telling me, okay, it's good to split read and writes in two different connections. And this was 30 years ago. So who is doing that now still? Who is splitting reads and writes in the code? Even if it's the same database at the end, but in the code you prepare your code to be able to send your read somewhere and to send your write somewhere else.
Well, there is like a whole CQRS architecture, if you know what it is. And this is still quite popular.
What it is?
Common query segregation principle. I think CQRS. Common query segregation something.
But do you use that?
I personally don't, but I know that it's still being used.
Because there is a lot of people they don't, and usually when I speak to developers, I have the same answer, yeah, why, no, but then when you go to in production, and your application is nice, it's cool, and it needs to scale now. Scale as Facebook scale, Booking.com scale. If you don't split reads and writes, if you are not possibility in your code to say all the reads will go in this replica, all the writes will go on this machine, it's an issue. So I invite you to start splitting by the beginning, when you start code, to split reads and writes. This is really things to do. So I try to, yeah, other disclaimer, I'm not a Java developer at all. So this is maybe my best Java code ever wrote. But you create two connections, once for reads, once for writes. They all go to the same server right now. Different users, always good to have different users. And so every time you know, because you should know if you are writing or reading in your code, it's best. So then your application will be prepared to scale, and to scale to something like this at the end. This is what people are using in production. So you have here, it's a group replication within a DB cluster, for example. You have read replicas here. You have disaster recovery on the other side. Every time we write here, we will be sending there. And we could have an extension of the connector, like on the connector J, which is the router that knows information about here, about say, oh, currently my primary master is this one, so I will send it there. But you should know that you need it's a writes or not. So your application will connect to the router, and router has two ports by default to say one for reads, one for writes, and then you don't care where it goes, but the router will do it for you. He knows it. But for you, you need to know it's reads or write. In case you don't want to do that because you say, yeah, I don't want to do this, then you can use MySQL router because it has a read-write splitting internally. But it has a cost. This is TCP level 7 proxy that will decode the SQL to find this is a read, this is a write. So it's that. If you are using JDBC, I don't know if you know that, but you can have failover connection in JDBC. You can specify many servers, so if one crash, you can go to another one. You can have load balancing in the JDBC that allows you to say, okay, if it's, let's say here, this is the read connection, and you can say, okay, oh, this is all my server where I can read from. And then it will load balance and read from different server. Or if you say, okay, I know we are using replication, we have a source of multiple replica, it is aware of replication also. You can do that in JDBC. So here, split your workload for reads and writes. It's very important. If you can do that, your DBA, your operator will be so happy with you. They will print the picture of you and they will put it on the wall, plenty of arts around it, because I have been in that team doing that, and it was a mess when we have to do it ourselves to fix all this stuff. So it's if you by design you do it, it's much better. But if you are using JDBC, there is multi-host connection that you should have a look. And if you don't want to do all this, use MySQL router with read-write splitting. It's possible to do it also transparently. Now I will give you some slides just to show you, because I will not go into the details because I cannot go into the details. It's slides about Java, all for Java users. You will have the slides, check the slides. So what happened is that I went to the team lead of the MySQL connector J, and I say, hey, what have you done new that I can share with MySQL to the Java users? And he said, oh, I will give you some tips for them, some information, and these are the slides. He gave it to me. To tweak performance, you have these settings now in JDBC, which I don't know, to be honest, but there are plenty of information. So you take a look at them. You will have the slides. You will have the video. If it speaks to you something, it's nice. If not, and you have question, send me after. I will send it to the team, and they can answer you for that. But you can see he sends me a lot of information about JDBC, They really love it. Something I didn't even know is that now you have multi-queries possibility. Watch out about SQL injection, but it's something possible to avoid round trip and stuff like that. So he sent also that information. Yeah, in preparing single queries, it won't work. And you can rewrite batches for you directly in the JDBC and in multi-statements. So some stuff like that. And I was also not aware of this, but I didn't know that when we were inserting, it was checking if there was duplicate keys, but you can disable that if you want. And yeah, once again, this is all for Java developers, and more and more and more, but we are run out of time. So there are plenty of configuration settings that you can be used to tweak JDBC. So take a look at it, take a look at the manual. There is plenty of information there too, but it also depends of your workload. So the next chapter I have, it's more about InnoDB itself for DBAs, not a long chapter. I don't know if you have time to do it or if you don't want to do it. It's up to you guys to decide. So who say yes, raise the hand. Who say no? Okay. So I will share you some secrets. If you go to ChatGPT or if you go to any Stack Overflow, whatever, and say, oh, I have issue with InnoDB, provide me information, and it will give you 10 InnoDB variables to change. Not true. It's not needed. If you know these secrets, most of the time it's enough, and I will share you with you. And yeah, you are not DBA, but you know what does full stack developer means. Full stack, it means everything, right? So the secret number one that I will share with you, right? It's very, very, don't tell anybody else. So maybe on YouTube, but memory is fast. So everything we can do in memory, we should do in memory. So disks are slow, even if we have fast disk, you know, SSDs and stuff, memory is always faster. So we should try to keep everything in memory. And what is the biggest, I would say, example of, let's say, consumer of memory in MySQL? Do you know? It's InnoDB buffer pool. So InnoDB buffer pool, it's where you should put all your memory almost. On the dedicated server, you can go to 90% of your memory allocated only for the buffer pool. This is where all the magic happens, buffer pool. So if you can have your working set in memory, everything will be fast. If not, then you need to find why it's not fast, and because you will need to read to this. So the first thing to do before telling, oh, Fred told me I need to increase my buffer pool or to check that, is to check. And the first thing to check is you can see when on your production server you run these variables, it doesn't cost anything. So you can run on production, it's just checking to a global status variable, and it will tell you how many times we have asked to read data, and the data we read it from the buffer pool, and how many times we had to read it from the disk. So as you can see here, the ratio is quite good. We don't read a lot from disk, so it's fine. Here we have no issue. So you can run the query like this to get the disk ratio. How many times do I need to read on disk? So here, my buffer pool, it's perfectly sized for the data I have. But I told you this was fake data, very small. I've seen here where the disk ratio goes very high, and then you have an issue, right? So if, in my point of view, if your ratio is above 10%, it's already a big problem. You should try to, of course, as soon as you start the MySQL, the ratio will be high because there is nothing yet, you just started MySQL, right? So, but you should take a look at that. Once you run MySQL in production for days, weeks, and you have checked that the ratio is high, I encourage you to take a look at this. Don't do that at peak time. This takes a lot of time to be executed if you do it at peak time. but this will provide you, and if you have a lot of data, it will be even lower, but this will provide you information about everything that is in the buffer pool. And you will be surprised. I run this in production to some customers, and they say, what? But this database, we don't even use it for 2 years. Why is it in the buffer pool? I don't have the answer why is it in the buffer pool, but it's in the buffer pool. There is somebody that keeps using that database somehow, or you do backups, or you do whatever, but that database, it's still in the buffer pool, and because what you have in the buffer pool, if you reach the end of it, it means that what is there takes the place for something else that should be there, right? So because then when there is no more room, it has to empty other pages that you need maybe to put new pages. Every time you read and write, these pages needs to go to the buffer pool anyway. It always passes via the buffer pool. So we can also use, for example, this query that will give us, okay, this was the buffer pool size, very small one. This is the percentage use, 69, and this is the percentage of dirty page. So now the question, who likes to see a small number here? Nobody? One? Who likes to see a lot of dirty pages here? Who doesn't like to see all the rest, right? Large number, better, right? So what does that mean? What is a dirty page? That's the first question, so, you know, before answering. What's a dirty page? So when you make a modification in, let's say you modify one record. This record is on a page, on disk. You check on memory, is this record there? No. So I will read it from disk. You take it from disk, you put it in the memory. This page is exactly the same. Then you modify the record. This page now, it's dirty because it's not the same as the one in the database, in the table space itself. Because we are ACID compliant, we wrote the delta or the change in the undo logs too, right, to be sure. These are sequential logs, but we don't care right now. The thing is, let's say dirty ratio is very low, and we want to keep it, we do everything we can to make it low. It means sometimes there is what we call the fuzzy checkpointing in InnoDB, meaning that all these pages that are dirty, we will write them back to disk. This is write operation. Let's say somehow we made that we want to have very low percentage here, because you can define that. And you write this page, you write it, and then you write it on disk. And then you say, oh, I want to modify the page. Like it's a counter, for example. Oh, let's put it dirty again. And it's better that it stays in memory. You change it, you do sometimes what we call it group commits. So you modify records that are in the same page, and when it's really needed, you will put it on disk. But if it's not needed, why do you need to spend time to write it on disk all the time, right? So if it stays in memory, it's good. So here, dirty pages, 90%, perfect, right? The only thing is if MySQL crash. What happens? Because all these modifications, where they are in the redo logs, and InnoDB, when you will restart, will do the InnoDB recovery. It means that it will change the pages to the last changes it needs to do from the redo logs. But that's it. You pay the price only there. So having the data, the working set in buffer pool is the best all the time. And what I see when I speak with developers, they say, oh, who's using Docker containers to make the unit tests or stuff like that? Are you doing that? Finally, people say yes. So my colleague Scott, is a developer advocate, will be very happy. He loves all that. The thing is that people say, okay, I have my test, and I run, I spin up my container, it does, and then it is slow. My query, it's slower than expected. And why this? When I was doing on my machine, testing without container, it was not that slow, and now when I spin up a new container, it's always slow. Because then the data, it's not in the buffer pool, right? So warming up the buffer pool has a cost. And like when I was doing a lot of performance tuning for big companies, being hot, so a warm buffer pool, can take weeks sometimes to have the working set in that buffer pool. And so what can we do? In fact, we have the possibility that provide a solution for this, and is this to say, InnoDB buffer pool dump at shutdown. So it means when we will stop MySQL, we will take the address of the pages that are in the buffer pool, and we will put them somewhere on the file system, on the data directory of MySQL. And when we will restart MySQL, we will load all these pages directly, even if nobody queries them, even if nobody asks anything on this page or write anything, we will put them in memory. So next time a query will happen, the pages will be in memory already. So you say, oh, this is cool, Fred. We can, when we stop it, we will save it. But let's say I stopped my server 2 weeks ago, and then it crashed. Then it restart, and it will load the pages of 2 weeks ago. But I have made a lot of changes. Maybe it's not my working set anymore. So this is why I recommend, for example, that because you can dump the content whenever you want. And so here, for example, I create an event. So it's like a cron job inside MySQL that every hours dump the content of the buffer pool. So if it crashes and it reloads, it will reload maximum 1 hour of data. Oh, it was. So this was the first thing, working set in memory. Do you know how we can reduce the working set? Do you have an idea? So if you now, we say we put the buffer pool as max as we can, and at the end, even if we use 90% of the RAM, we still see that we do a lot of read from disk. What can I do to reduce my working set? There are some ways to do that, and it is remove the duplicate index, remove the unused index, don't do full table scan, and if it's not enough, start thinking about partitioning your data. So when you do big selects, maybe you will select only part of the index or part of the data that is in the partition, right? So this was the first thing, working set in memory. The second thing, now it's when we write data, it's the redo log capacity. So this is the second settings I wanted to share with you. InnoDB log capacity, it will allow you to define the writes capacity you have and how many times you will flush to disk, because it's the flushing to disk that is slow, and it is slow because it's a disk, and then sometimes when you are forced, it's not because you are doing it, it's just because you are forced to do it, and then that's costly because then it froze, it stopped the world almost. So what we do here, for example, I don't know why he put this star there, but okay. You run this query, right? And you can see that this query has semicolon, but it's in one line query. You run the query takes 1 minute to be run, right? And then we have this information. You run the query at peak time, so when there is a lot of writes happening, and we can see that this minute we wrote 6 megabytes. And per hour, this is 340 megabytes that we have wrote. And the rule of thumb for InnoDB to do this fuzzy checkpointing like it should, it's to keep in the redo log 1 hour of data. If we can keep 1 hour of data in the redo log, InnoDB will write and clean the dirty pages the smoothest way as possible. And to do that, so now that we know that it's this per hour, we say, okay, I will put InnoDB redo log capacity to 350 megabytes instead of what I had before. That maybe, like in the old days, the default was 2 files of 5 megabytes, so 10. So now it's always 32 files, and now we will put 350 megabytes for the entire 32 files. If you're really interested in checkpointing and all that kind of stuff, videos, slides, I have sessions on that explains all that for a lot of time. And I can answer after with the beer all these questions, no worries. So now your working set needs to be in memory, so you need to check the buffer pool usage, and you need to keep the ratio very low from read disk and the one read from memory. Run warm as much as possible. So, for example, if you do test, maybe it's nice that you dump the data, you dump the buffer pool, then you restart your server, and then you load the buffer pool before tapping your test. So it's already warm. check the redo log capacity you have, and keep it sized for 1 hour, right? If you say, yeah, it's nice, but all that is maybe too complicated for me, we have done something for you to start with, and this is InnoDB dedicated server. So I told you, please don't modify MyCNF, but for this one you can. So you put that in MyCNF, InnoDB dedicated server equal 1, and MySQL will tune the memory. It will check the memory you have, it will check the CPUs you have, and it will configure automatically MySQL for the best usage. Now maybe you still need to tune something later, but at least this is the best way to start with. Not using the default, but using what it's best for your machine. But now if you say, okay, I run this and I have 10 MySQL on the same machine, it will fail because they don't know about the other 9, and so they will all try to keep all the memory for them, right? So this is very bad. I thought about adding some limits. So this is two settings for you, the developers, is that maybe you don't know this, max execution. This is what we call an optimizer ins. So when you do this in your query, max execution time, and you give something in milliseconds here, and for example, I do sleep 10, it should stop after 10 seconds, right? But in fact, here after 5 seconds, the query stopped. So if your query goes more than that time, it will stop. So you can add limits to your queries. And more for the DBAs, you can change that directly in the query write plugin, for example. If you know that people are running bad queries, and depending at what time they run it, it's way too long, you can add this max execution time without telling the developers. And the same for limits. So when you do a lot of row and you forget to add a limit, and then the production goes down almost. So what you can do is say, not 5 of course, but as the DBA you can say, okay, the select limit should be 5,000 records. What do you want to do more than with more than 5,000 records, something like that. And so here just put it to 5 to show you. I do select, and my select ends at 5, right? You force that limit, right? You can do the same for the memory. So you can enable memory tracking, and this is why performance schema is needed also. You can say, okay, I want to enable it, and I want that all some connection doesn't go above certain limit, right? And here, for example, put 16 megabytes for a connection, which is nothing for all the connections. And if somebody goes above the connection, it says, oh, watch out, you are consuming too much memory in your connection, so you will get out. So for developers, I want to also show this, don't wait, because maybe you are not aware of these two settings. So here I have a session and I start a transaction. I do an update from some records, and I don't commit, I don't roll back, I just update. So what happens in other connections that will use these rows? Do you know? If in another connection I come and I want to go in reviews and change something for that product ID. It's locked. For how long? Until I say yes or not, or the transaction timeout, right? It's only be locked wait timeout. So 50 seconds by default. So if I do select that product I wanted for update here, you know, that means I want really to update it, so I want to select it, and then I will update it. I wait, I'm waiting, 50 seconds after, if I don't roll back or commit the other one, I get ejected and say, okay, I cannot select that for update because it's locked, right? And this 50 seconds, I don't recommend to change that time, to say, okay, just wait 2 seconds or 1 second. It's a bad idea. What you should do, if you don't want to wait, it's to use these two new keywords, no wait or skip locked. So for example, I say I want to do the same select for a bit, but this time I say no wait. I don't want to wait. So if I have access to it, I will be able to select it for a date. If I don't have access, just say, okay, you don't have access, it's locked by somebody else, and that's it. You don't have to wait 50 seconds, right? Or you can say, okay, I want to select. Here it's not a range, it's just one ID. But and then you say, okay, I want to select this for update. There is none free, so I don't have any record coming out. If it was a range, because people say, okay, but why is it valuable to use that? Let's say that you want to book airplane tickets, right? And you say, somebody say, oh, maybe I will, I want to do my, what do you call it, my check-in. And I have the room, the place 2659 booked for me already. But I say, oh, I want to change place. So this one is booked for me right now. And I didn't say which one I will select. Then somebody come and say, oh, I want to select, to do my checking too. And I want to also select another place. The one that is booked by this guy for the moment, I will not be able to check it, because maybe the guy will cancel, maybe the guy will just stop the application or whatever, and you don't want to book twice. So you will give me all the rooms, but that one, don't show it to me because it's still locked. It's not yet sit on it, but it's locked, for example. So you say, okay, skip locked, and it will provide me all the ones that are not locked, but free, for example. So this is where it works very well. So cap the query time, cap the amount of return rows, limit the memory connection, don't wait for locks, and that's it. Do you have questions?
Can you explicitly exclude some database or table from the buffer pool?
Say that go never in the buffer pool?
Yeah.
No. You can't do that. Because every time you read or write, you have to be in the buffer pool. There is no way to not go in the buffer pool. So you cannot do that because it's it's the way it works, right? So and then let me see. No, I think no, you can't put them out of the buffer pool. There were some tricks before, but no, you cannot do this. But it will always be there. Sometimes you can. There was some way to put them out quicker than what expected, but normally you are not able to do that, and you cannot say, okay, I don't want you to be in the buffer pool. Yes.
If you set the default limit, does this apply to also to nested statements and stuff like insert into select? Does it also apply to those?
Insert into select, I think so, but it should apply there. It's a nice question. I need to check that too again also. But normally, yes, it would, because it's sub-select at the end, so it will do it. Other question? Yes.
Maybe stupid question, but with the connection memory, what kind of data are there? Just the query and the data return, or some interesting data are there stored also?
Yeah, in memory can be a lot of stuff, right? When you do a connection, all the buffers that sort buffer, all that kind of stuff, are there for you. Yes.
So not only the results.
Yeah, not only it's all the memory that it's used by the connection. So every time. Sometimes people they put, oh, let's say I will allocate this for my big queries, and then you say max connection 1000, and every time you connect, you will allocate this memory, and then you say, oh, what's there is this OM killer that kills MySQL for what reason? Was not running anything. Yeah, but you try to connect to it. You can make many connections. You allocate it to 4 gigs or whatever, and then. If every connection uses 4 gigs, it's impossible to keep on, right? So, other questions? So I think it's beer o'clock. Thank you.